WarsawJS.
Okay, so hello everyone. It's very cool to see so many people in person. My last few presentations were mostly virtual, so it's very cool to see such a huge crowd. I don't have much time, and we have a lot of topics to cover, so I'll be very swift. I'll be coding in TypeScript and using JEST. So if any of you have any questions for the language, anything essentially, hit me up later. You can use the typical WarsawJS methods. I'm not sure to the people online what are those, but you can ask questions. And one more thing is that this presentation is heavily inspired by a blog post that is incoming in the future by my colleague who is also here. So if you have any questions, want to read later a summary of this, but in a text version, then it should be at our blog post. So I'm Michał Warda, and I'm the CTO at Elpassion. And my presentation topic today is purposely failing. So I'll be mostly talking about TDD and BDD, mostly even coding about TDD and BDD, because we don't have much time for talking. Everyone knows that programming is about programming. So I'm going to start with writing a very simple program. This program is called FizzBuzz. If you ever did TDD, probably the first program you wrote or found online is FizzBuzz. The rules are pretty simple. It's a children's game, but codified. Write a program that for a specified positive integer n returns a table of length n with string matching rules. For every number that is not divisible by 3 or 5, return the index value. For 3, return fizz. Divisible by 3, return fizz. 5, buzz. And 3 and 5, return fizzbuzz. If you pass in an incorrect number, for example, a negative integer, then an incorrect size error should be thrown. So an example of this is if we send fizzbuzz of 16, then the output is an array with correct values. So it's time for the demo. I hope everything will work correctly. Okay, so all of my code will be done in TypeScript and using at least TDD. So let's pray that everything works correctly. So I'll start my FizzBuzz implementation by covering the edge cases. So first, I'll say that when I pass a 0, so FizzBuzz returns empty table for 0. So essentially, if I call a function FizzBuzz with size 0, then I expect that the value of it to equal empty array. I've already created a file with this function. I'm not gonna lie, it's empty. So so if we do it this way, I have my test runner here. So if I launch those tests, then beautiful, we have those working. The first test passes. Now I would commit, etc., but I don't have time for that. I need to code further. So let's cover the other edge case. So it throws an error when a negative number is passed. So I'll expect that when I call FizzBuzz with -1, it should throw an error, incorrect number error. I'll launch the tests. Yes. Okay, we have an error. So it's time to implement it. Obviously, if size is less than 0, throw new error, incorrect number. Okay. I rerounded specs. Okay, everything is working. Again, commit, and let's further develop. So the next test is let's try to maybe do something about with this fizzbuzz. I'll for returns array with one item when passing one, and then I expect that fizzbuzz from one should equal an array with one. I'll launch the tests. Should fail. Yes, it failed. So here, rather than doing a simple array here, I'll return I'll create a new array, and the length will be the size that I'm passing. And for each item in this array, I'll take the item, which is not required here, and I'll take the index. And I'll return index plus 1. Essentially, error, sorry. Anyone sees it? One more. Oh, yeah. Thank you. I'll be, to keep it consistent with the text, I always return a string. Okay, so we have the second thing covered. So we've implemented that one returns one. The next thing probably would be to handle at least 3. So returns array with 3 items and fizz instead of 3 when passing 3. Okay, I'm writing casing because it's easier to always write it rather than forget about it. 2 equal, and we need 1, 2, and 3. I'll rerun the tests. Oh yeah, it shouldn't be this, it should be fizz, obviously. Okay, and it failed. So right now I should cover this, that add braces. I'll do an if statement here. If index plus 1 is divided by 3 is equal 0, return fizz. Index, no. Index plus 1. And this, and right now. Okay, 3 is covered. So now let's do 5. And doing 5, we don't have much time. I'll do 4, which is not divisible, and buzz. And now I need to pass 5. I rerun the specs. Obviously, it will not work. So I also check that if the index plus 1 is divisible by 5, then I will return buzz. Okay. No, the tests didn't run, or think. And OK, we have fizz buzz working. The last thing is obviously to cover the 15, which if we'll cover the 15, we'll also have all the different cases. Essentially, the first number that is divisible by both 3 and 5 is 15. And all the numbers that are divisible by 3 and 5 are divisible by the multiplication of those numbers. So essentially, we are checking if it's divisible by 15. And I'll do the same thing. I'll do the same thing here with 15 items. And fizzbuzz, here was buzz. And fizzbuzz instead of 15 when passing. And I'll do this like this. So now is the hard part. Fizz here, then 7, then 8, then fizz again, then buzz. Oh, then 11, then fizz, which is then 13, then 14, then fizz buzz. Check it. Should fail at fizz buzz. Yes, because it wrote fizz. So to do it correctly, I need to divide by 15, check if it's divisible by 15, and return buzz. And many of you, which have already done this task, might find it odd that this is the method that I'm using. Don't worry, I know it. So we've covered essentially the whole fizz buzz. Again, maybe non-integers, if we pass non-integers to this function, will fail. But other than that, we've covered the whole fizz buzz. So we have it ready. So let's move to a harder example. The other one is game of life, which I'll also try to code. And game of life, does anyone know game of life here? Yeah, some of you. Game of life is a program that, the simplified version for you, is a program that takes a 2D array board filled with cells, ones or zeros. 1 means a cell is alive, 0 a cell is dead. And there are essentially 3 rules. A living cell with 2 living neighbors survives, a cell with 3 living neighbors survives or revives, and all other cells die or stay dead. Essentially, you can look at it right here. Every tick, we have an array of items, and in the next tick, we check the state after it. So this cell has 1 neighbor, so it should die. Yes, it died. This cell has 1 neighbor, so it should die. Yes, it died. And all of the other rules apply. So right now, I'll implement game of life in TDD the same way I did with FizzBuzz. So game of life is a much harder topic than FizzBuzz, but let's try to do it. So first, my goal is to check that if I pass an probably empty state, so we'll work on 2D table with 3 items lengthwise and 3 items heightwise. So if I pass an empty board, we should get an empty board back. Returns empty board after passing empty board. So if I run game of life with, I expect that when I run game of life with 0, 0, 0, don't worry, it will format in a second and it will look. If I run this code, I expect it to return the same board. So 0, 0, 0, 0, 0, 0, and 0, 0. So if I run this, then I should get back the same board. Maybe not the same board, but a different board, or maybe the same board, whatever. It should look like this. Okay, I have 2 compilation errors. Now is it working? Yes, it's failing. Perfect. So it's failing because I didn't implement it. I'll just return the board. It looks the same, so I'll just return it. Okay, works. Beautiful. So now the next step is obviously to add another thing to it. And I'll do it, I'll pass a 1 here, for example, or maybe to simplify it for now, I'll pass a 1 here. And the boards should still be all zeros, because this one does not have 2 or 3 neighbors, so it should die. So the output should be zeros, and the output, I only launched 1 spec, sorry. What? 1 second. Turns the board. I'll launch maybe only this spec. Sorry. Come on. What's happened? Oh, it has the same name. Sorry. Returns empty board after passing board with only one cell. Okay, now it should work. Now it should work. Yes. Yes, it's failing. So the answer here, the simplest TDD way of doing it is to just return an empty board. But soon enough, and this is the whole point of this this presentation, is that we'll hit a wall by doing it this way. And this wall will be hit very, very, very quickly, as you can see, because the next step is to implement at least a tiny bit of logic here that tells the game of life how to do it. And for example, in game of life, when you have a board like this, then after you should get a board like this. It's called a cross. And the cross just changes from this to this, from this to this, from this to this. It's a perpetual motion. And if we run all of our specs, please work. Again, the name, cross works. I don't have much time, so don't worry about the naming. No, I've changed the wrong spec here. Cross works. Then it obviously does not work because I return a table with zeros. And here is the moment that that is very tough for many programmers, especially those who don't code with using TDD or BDD. It's that when we stumble upon a wall that is immovable and it's too hard to write, because essentially the next part of trying to fill in this requirement would require at least, I don't know, 10 minutes from me to fill in one of those, to solve this one test. In my version 0 of the presentation, I fail, but we don't have enough time here to see me fail. So, we need to split this test into other tests. So it doesn't mean that this test is wrong, but it means that we need a deeper understanding of the problem, and we need to split the problem into smaller ones to be able to solve this, this problem. And when we write a test that we know is failing, and we know it's good, and we want to use it in the future, but we know that we cannot currently use it, we can add a new feature that was introduced in JEST 28.1. It's called failing, which means that it's different from skip. Skip just does not run the code that is here. Failing runs the code that is here, but if a test fails, it passes. If a test passes, it fails. And don't overuse it. It's not for the purpose that if you have a test that you never wanna, if you wanna you want it to stop failing, then you just add failing. It's for the purpose of a situation like this, when you add it for when you write a test and an implementation and the implementation of the test, and then you know you need to make smaller steps to achieve the goal. So what are our steps to achieve the goal? First, in TDD, we need to move a step back. So essentially, if you stumble upon a problem like this, it means you're already way too far. You should refactor, usually. And the first refactor that I'll introduce here is I'll introduce a function. I'll introduce a function called goal cell. And this will take a board, which is the same thing, and it will take two coordinates, an x and a y. And I'll return a 0 for now here. And here, for the board, I'll map, I'll do a row and a y. or even I don't need a row, sorry. I'll do a Y here. Oh, I need a row, but I don't need it. Like this. And for every row, I'll map and do a column and do an X. So all and an X. And for each one of those, I'll call a function goal cell, which I'll pass a board to, and the X and the Y. My tests should still pass, I mean fail. One of those failed, but I've marked it as failing. And now it means that I can test this part without testing this part. So essentially, I can implement a logic of how one cell will behave rather than trying to implement the logic of the whole program at once. So I can write a test for a goal cell that if a cell has returns one for each. No, sorry, I'll look at the rules. A living cell with 2 living neighbors survives. So returns 1 if 2 living neighbors are present. So rather than doing that part, I'll expect that the goal cell from board. I need to pass the board. So I'll create one very simple one. So from the perspective of cell, a returns 1 if 2 living neighbors are present. So this cell should survive. So I'll pass coordinates 1 and 1. And this board, so I'm saying that this cell should survive, and I'm checking it by running 2b1. Obviously, it will not be 1 because it's 0. It's implemented as 0. So somehow, right here, I need to check how many neighbors are there, and somehow I need to specify that if there are 2 neighbors, then return 1. Unfortunately, I don't have the algorithm of finding the neighbors yet. I can have an algorithm of if there are 2 neighbors, then I should return 1. So I'll do it this way. If there are 2 neighbors, or maybe not, it means that, again, I need to go deeper. It means that this spec should be a failing spec, because I cannot finish it in like a minute or 2. First thing I should come up with is a thing that returns the number of alive neighbors. So returns amount of alive neighbors, returns 0 alive when 0 alive. So I can do from the perspective of goal living neighbors. Time running out of time very quickly. What's the time? Out of time? No. 2 minutes. 2 minutes. Can I have 2 minutes? Piotr is on his phone, so I can have 2 minutes. So I'll do it very quickly right here. So the algorithm to find neighbors is, and I'll use my sorry, don't have that amount of time here. So essentially the algorithm to find alive neighbors is this. We take the board and we just take all of the neighbors, so essentially 8 cells that are around us, and we can do it as by coordinates, and we just filter the alive neighbors. The tests that we need for this to happen are those. I'm gonna, oh shoot. This didn't go well. So the tests that we need for it to work are essentially that if there is an empty board and we specify it should return 0, if there is one alive neighbor from the perspective of this one, we should return 1, and if there is a non-existent, from the perspective of this one, if we're out of bounds, we should still treat those as correct neighbors, as essentially dead neighbors. And the algorithm to that is here. It would take around 5 minutes to implement it, and then we can use it in the goal cell, obviously, this algorithm, to check that if there is a one alive, if the state is 1 and there are 2 alive neighbors, then we should return 1, and if there are 3, then we should return 1, and if there are none or any other number, then we should return a 0. And if I run this code, I think it should work, but you didn't see how I wrote it. 20 minutes is not enough to do it. Okay, it works. And essentially, the crucial step here was, oh, no, it wasn't this code. I can still do it. So the crucial step here was that if you wrote this super duper code and it was failing, you've marked it as failing previously, and you, please, yes. If you've marked it as failing, then it just would throw an error. So the failing test passed even though it was supposed to fail. Remove failing to remove the error. You remove the error and you run the test again and you get it. So to sum up, in testing, if you stumble upon a test and the implementation would take you more than 5 minutes, you're writing a bad test. So essentially, maybe sometimes you write a bad test, sometimes you write a test that you should write in the future, but not right now. And also, if you stumble upon a test that you know is correct, but you cannot find time to implement it yet, then you can use the new just failing feature. And that's all. Thank you. Any questions?
You told us about TDD, test-driven development.
Yeah.
And I'm curious about your opinion on DDT, which is development-driven test.
DDT?
DDT, yes, all the way around. You first write the implementation and then, oh shit, tests.
Okay. I mean, it's incorrect, but I want to make a joke out of it, but I cannot come up with anything. So essentially, it's impossible. Writing tests first will change the design of your code, for sure. It's impossible to write. It's much harder to write bad code when writing tests first. It's much easier to write good code when writing tests first. And also, it's much easier to write good tests when you know what you're writing. This FizzBuzz thing also had a next step. So if you had this code running, then FizzBuzz, those tests that we wrote also weren't good tests at first, because our tests were checking a lot of things. In FizzBuzz, we also should have split the code into another function that was essentially checking that the divisibility works and that correct numbers are printed for everything. If we didn't write tests first, I wouldn't come up with an idea to even try to split this code into 2 parts. But the fact that I had tests made it much cleaner, essentially this part. So my opinion is that I don't want to scare people from talking to me, but I think that we only can write tests first. Like, I had a boot camp, and my boot campers hated me because they are sitting there, so they don't hate me that much. Yeah, they still hate me because I told them to write everything in TDD, but they love me now. Yeah, thanks to that. So it's the only option for me.
Okay, thank you very much.
Okay, any other questions?
It's like everything's clear, and only true warriors have the guts to do live coding. So thank you one more time.
Thank you. Thank you very much.